let's move on to the next speaker.
Okay, let me go ahead and share my screen.
Okay, so our next speaker is going to be Olivia Jeffris. And she's working with Professor Jernigan and Nitz and postdoc Claire Palmer. And she will be talking to us today about factors associated with individual differences in reading performance of 10-year-olds.
Okay, can everyone see my screen? I'm assuming
yes.
Yes. Okay, great. All right, so hi everyone. Thanks for coming to my cognitive science honors talk. My name is Olivia Jeffris, and the title of my thesis is Factors Associated with Individual Differences in Reading Performance of 10-year-olds. So a lot of studies in the literature have identified numerous factors that associate with school-aged reading performance. And some of these factors that associate with reading performance include socioeconomic status, or SES, which we define as annual combined family income and highest level of parent education. Also psychopathology, enrollment in gifted programs, speech development of children, and a child's intrinsic motivation to read are all shown to associate with school-aged reading performance. And so a lot of studies suggest that the factors that I just reviewed might also be related to one another in some way. And so there are relationships in the literature that are established between linguistic factors and psychopathology, between SES and psychopathology, SES and gifted programs, bilinguality in gifted programs, and gifted programs and reading for enjoyment, or recreational reading as we call it. And so, but the overlap and the shared variability among these variables that I listed has not really been fully investigated in the literature. So previous studies look at each of these variables as having an individual effect on reading performance because they didn't have the scope to look at multiple measures that associate with reading. And so as a result, the overlapping variability in reading performance explained by multiple variables remains largely uninvestigated, and particularly the shared variance between these variables and SES remains uninvestigated. So in my project, I focus on the overlapping variability across many variables to explain the reading performance. And so when we think about factors that directly associate with reading performance, we first expect to see relationships with factors like linguistic development, bilinguality, recreational reading, and academic factors. And then other factors that we think might be associated with reading but maybe don't have direct mechanistic influences include screen time, sleep, psychopathology and temperament, school and neighborhood environment, psychosocial environment, and SES. Additionally, SES is shown to be associated with a lot of these factors themselves. So this suggests that there might be an overlap in the variance in reading performance explained by SES and all these factors that I just listed. And so the ABCD study, which is a national longitudinal study that collects data from over 11,000 children aged 9 to 10 to track factors that associate with their development, is uniquely equipped to investigate factors that associate with reading in 10-year-olds. So the ABCD study provides the scope to investigate the shared variability among multiple measures because this study tracks thousands of factors. And it also provides the power to get reasonable estimates of the effect sizes with small confidence intervals because of the large population that this study tracks. And so the aims of my project include to determine the extent to which variables across SES, individual factors, and environmental factors can explain individual variability in reading, to determine the extent to which variability in reading performance is shared amongst these predictors, and to determine the extent to which SES mediates the associations between these predictors and reading. And so reading score is the main outcome measure of the study, and we define it based on the NIH Toolbox oral reading recognition test scores of the participants. And so When they take this test, basically what it is participants are going to be presented with words and letters, and they have to read and pronounce them as accurately as possible. And then they receive a score based on this examination. And then my variables of interest, my predictor variables, were studied either individually or as part of a behavioral domain, which I listed earlier in this presentation. And they're listed here again with all of the variables that fall underneath them. And then they are continued here, all of the variables. And so the method that I used is a linear regression model, and this is the notation for it. So the y is the dependent variable, the beta sub 0 is the intercept, beta sub I is the slope of the line between the independent variables and the dependent variable, and then x sub I represents the independent variables that I'm looking at. The 1 over family is the random effect, and this accounts for the relatedness between families. So it allows to have a different intercept for each family. And then lastly, the epsilon is the error term, and this represents the variance in the dependent variable that's not explained by the model. And so to determine the variability in reading explained by age and sex, age, sex, and SES, age, sex, SES, and all my variables of interest, I generated these 3 models that all predict reading score. And so each linear regression model in each of these 3 models yields an R² value, which is a statistic that tells you how much variability a given set of predictors can explain in an outcome measure or a dependent variable. And so we can see that after running those 3 models that I just went over, age and sex account for 4.84% of reading score variance. Then adding SES, the purple bar, explains an additional 9.26%. And then adding all other variables explains an additional 19.7%, we can see in the green bar. And so to determine the variance in reading score explained by each variable, I generated a bunch of different models with age, sex, and 1 variable of interest as predictors seen in model 1. And then I took the R² value for that model, and I subtracted the R² value from the age plus sex model, which is model 2. And so this delta R² value, when I subtracted these, shows us how much variance each variable explains on its own when controlling for age and sex, because I've omitted the variance associated with age and sex. And so after I ran all of those, I get this graph here, and this is a result from those analyses. So you can see on the y-axis, you see all of the predictors listed. And then on the x-axis is the absolute delta R² multiplied by the sign of the slope between each variable and reading score. And so each of these variables is also grouped into a different color depending on the domain that they belong to, as you can see in the key in the right-hand corner. And so basically what this graph is showing us is the reading variance explained by each individual predictor controlling for age and sex and the direction of that relationship. And so now I'll break down this graph a little bit because it's kind of a lot to digest. It's a large graph. So we can see that higher reading scores associate with less speech delay, more English proficiency and bilinguality, more time spent reading for recreation, and then lower reading scores are associated with enrollment in special education programs, while higher reading scores are associated with enrollment in gifted programs. Higher reading scores are also associated with less screen time, more sleep, and then it's also associated with higher self-confidence and problem solving, more anxiety and depression problems, less attention problems, and higher sensation seeking, whereas the rest of these psychopathology factors have a negative association with reading score. High reading score is also associated with a safer perception of one's neighborhood and being less disengaged and more involved in school. Also associated with more parental monitoring, less family conflict, less perceived discrimination, higher parental acceptance, and less pro-social parents, and higher SES. There's also a moderate relationship between reading score and ABCD site, which is just the site that the data was collected at for a given participant. Okay, sorry. And so to determine the amount of variance in reading explained by each behavioral domain, I ran models with age, sex, and one domain of predictors or in one domain of variables as predictors, which is model 1. Then I took the R² value for that model and I subtracted the R² value for the age plus sex model 2, to get the delta R². And so this delta R² shows us how much variance each domain of variables explains in reading, controlling for age and sex. So it's kind of, it's similar to the models that I just ran, but now we're looking at the domains instead of the individual predictors. And so this first part of the graph shows the results from those analyses. The purple bars show the variance explained by each domain when you're controlling for age and sex. And then to determine how the amount of variance in reading explained by each of these behavioral domains overlaps with SES, I ran models with age, sex, SES, and one domain of variables as predictors. That's model 1. And then I took the R² for that model and I subtracted the R² from the model with age, sex, and SES as predictors to get the delta R², which in this case shows us how much variance each domain of variables explains when you're now controlling for age, sex, and SES. And so in this graph, we now see the results from that. So the difference between the purple and green bars shows the shared variability in reading score explained by each domain of variables and SES. So basically, once we control for SES, which is shown in the green bars, the R² values associated with each domain of variables drops from what it was when you're controlling for just age and sex, which is shown in the purple bars. So basically, once SES is added to my models, each domain of variables explains less variability in reading on their own. And so this means that there's an overlap in the variability explained by SES and the domains of variables in reading score. So basically, looking at this graph, we can see that there's a shared variability with SES for nearly all domains, and particularly for sleep. And so the last analyses that I ran to determine how the amount of variance in reading explained by each behavioral domain overlaps with other domains now, I ran models with age, sex, SES, and all domains as predictors. That's model 1. And then I individually omitted each domain of variables from the model temporarily, which is seen in model 2, to get the delta R² when that domain is missing from the model, just that one domain. And so I subtracted the R² from model 2, or for model 2 from model 1 to get the delta R², which shows the unique variability that each domain explains in reading. And so now we see the results from that. So basically the next drop that we see in delta R² is seen in these yellow bars, and it shows us the shared variance across all factors when you're predicting reading. And so this is because the yellow bars show the unique variability accounted for by each domain when you're controlling for everything else in the model. So once we control for all domains in the model, seen in the yellow bars, the delta R² values associated with each domain of variables drops from what it was when you were controlling for just age, sex, and SES, which is seen in the green bars. So basically, once all of the other domains were included in the model, each group of variables explained less variability on their own in reading. And so this means that there is an overlap in the variability in reading explained by all the domains. So to recap, looking at this graph, the difference between the purple and green bars shows the shared variance between each domain and SES, while the difference between the purple and the yellow bars shows the shared variance across each domain and all other domains when predicting reading. And so now I'm going to go over some of the potential mechanisms that could be driving the results that we see. And so the results suggest that there might be overlapping variability between recreational reading and academic factors with SES and with one another. So we saw shared variability between SES and recreational reading. One hypothesis is that we see in literature that children from low SES have less exposure to literature at home, which could entail fewer opportunities for recreational reading then less developed reading skills and subsequently poor reading performance. We also saw shared variability between SES and gifted programs. And so based on the literature, we can see that children from low SES tend to be underrepresented in gifted programs. So they might receive less advanced reading instruction as a result and potentially have poor reading performance. We also saw shared variability between gifted programs and recreational reading with other domains. So I hypothesized that there could be some overlapping variability between these two specific variables. And so the literature suggests that children in gifted programs spend more time on recreational reading, which then suggests that they might spend more time developing their reading skills. And as a result, I believe that they would potentially then have a higher reading performance. There also may be overlapping variability between screen time factors and sleep factors with SES and one another. So we saw shared variability between SES and screen time in the analyses. And so a possible explanation for this relationship is that children from low SES have more screen time, which suggests that they spend less time reading and may then have poor reading skills. We also saw shared variability between SES and sleep. And so the literature shows us that children from low SES have more sleep-related issues, and a lack of sleep has a negative effect on cognitive functioning and academic achievement. So that could then entail a poor reading performance. We also saw shared variability between screen time and sleep with other domains. So I hypothesized that there could be an overlap specifically between screen time and sleep. And so I can see in the literature that children who have more screen time get less sleep, and then also having restrictions in sleep is associated with poor cognitive functioning and academic performance. So this could then lead to potentially poor reading performance. So quick recap. So recreational reading, academic factors, and SES yielded the largest effect sizes on their own. So they explained the most unique variance in reading score when controlling for all other factors. And then all the behavioral domains in the model were mediated by SES and one another in the variability that they explain in reading performance. Additionally, I went over some potential mechanisms that I think could be driving the relationships, but I did not, but these kind of hypotheses, that's what they are. They have to be substantiated by stronger causal evidence. So I can't really draw any conclusive theories about why these relationships exist. I can just identify the relationships themselves, which are still meaningful and important because these relationships can be now explored further in an experimental setting and potentially help uncover interventions to improve adolescent literacy. So I want to thank Dr. Claire Palmer and Dr. Terry Jernigan for giving me the opportunity to conduct this project and for supporting me every step of the way. I couldn't have done this without you both. I want to thank Dr. Nitz for your mentorship, Dr. Kudus for your guidance and support throughout this, my honors cohort for your encouragement, and my family and loved ones who are here right now for your continued support. So now I have a bunch of references, and I will take any questions that people have now.
Great, thank you.